All right, so today we're going deep, diving headfirst into the world of plasma.
Oh, yeah.
But not just the regular stuff.
No.
Like, we all know about lightning bolts and neon signs and all of that.
Right, those are cool.
But what we're really here to explore
Yeah.
is the connection between plasma and, get this, UAPs.
And that's where things get really interesting.
It's a bit of a mind bender, right? So before we get ahead of ourselves,
Sure.
let's start with the basics. What exactly are we talking about when we say plasma?
Okay, so you know how we have, like, solids, liquids, gases, the basic states of matter?
Yeah, everyone remembers that from school.
Well, plasma is often called the fourth state of matter, and basically,
yeah.
it's what happens when you take a gas and you superheat it, like really crank up the temperature.
Uh-huh.
The atoms in the gas, they get so much energy that they start losing some of their electrons.
Whoa.
And that's when it gets interesting, because now those atoms are electrically charged.
So it's like a supercharged gas?
Exactly. And as wild as it sounds, plasma is actually the most common visible state of matter in the universe.
Really? I wouldn't have guessed that.
Oh yeah, think about stars. Our sun. Giant ball of plasma.
Oh, right.
Yeah, it's everywhere out there.
But you said visible. Why is that? Like, is there invisible plasma?
Well, kind of. We know there's dark matter and dark energy out there, and we can't actually see them.
Yeah, that's that whole other mystery.
Exactly. But for today, we're sticking with the plasma we can see,
Good plan.
which is still a lot.
So, stars, obviously. But we've got plasma here on Earth, too, right?
Oh, absolutely. Everyday stuff. Think about lightning, that bright flash. That's plasma.
No way. I never would have connected those.
It's true. Or those auroras, those northern lights up near the poles.
Yeah.
Pure plasma right there.
Oh, wow. And they're so beautiful. I was actually reading on plasmauniverse.com
Oh, yeah, they're amazing.
about how these lights, these plasma curtains, they shimmer and move and dance.
Like a light show, right?
Yeah, they called it a celestial ballet, which I kind of love.
It's a good way to put it, because it really is all about energy and motion and these incredible interactions. And those interactions, they're not always so gentle.
Right. Because when we're talking about plasma, we're also talking about some serious power.
Oh, absolutely. Like, think about solar flares, right? The sun just hurls out these massive bursts of plasma.
And those can mess up satellites, even cause blackouts here on Earth, right?
Exactly. And even lightning, as common as it is,
Yeah.
it's a good reminder that this stuff packs a punch.
So we've got this powerful substance, it's swirling around in stars, causing auroras, even crackling in thunderstorms. But where does the whole lifelike behavior come in? That's the part I'm really struggling with.
Right. Right. And to understand that, we got to dive into a specific type of plasma.
Okay.
This is where things get really wild.
All right.
It's called dusty plasma. And trust me, it's way more interesting than it sounds.
Dusty plasma. Okay, so it sounds kind of like something you'd find like under your couch.
Right. A little less exciting.
Not exactly screaming UAPs at me, you know.
It does sound kind of mundane, I'll give you that. But dusty plasma, it's way more than just some space dust bunnies.
All right, I'm listening. Convince me.
So imagine regular plasma, right?
Sure.
All that energy, those charged particles. Now toss in a bunch of tiny dust particles.
Okay.
These particles, they're not just floating around randomly. They actually change the whole game because they respond to the electric fields in the plasma.
Okay, so they're like interacting with the plasma itself.
Exactly. It's
Yeah.
like, imagine throwing a handful of confetti into a tornado, right?
That's a chaotic image.
You get these crazy swirling patterns. That's kind of what's happening with dusty plasma, but on a microscopic level. And the things they're seeing in the lab.
Oh, this is the lab stuff you were talking about.
Yeah. So they're doing all these experiments, and the things they're seeing are pretty mind-blowing.
Like what?
So these dust particles, they start to spontaneously organize themselves, like all on their own.
No way.
Yeah.
Seriously, they just arrange themselves.
I know, right? It's crazy. And not just random shapes either. They're seeing helices, spirals, even formations that look kind of like cells.
Wait, hold on. Cells. Like the building blocks of life.
It's wild, right? And the way they move, too. It's rhythmic, almost like a pulse.
So you're telling me just by adding dust to this plasma, you get these organized structures and movements that kind of look like life?
In a way, yeah. Now, to be clear, we're not saying dusty plasma is alive, at least not in the traditional sense. It doesn't have DNA or anything like that.
Okay, good, because I was about to freak out a little.
But it does make you wonder, right? If something can mimic the complex behaviors of living organisms without actually being biologically alive, what else is possible?
That's a big question for sure. And it kind of makes me think about those NASA observations, the ones from the space shuttles you mentioned earlier.
You're right on track. Because what those observations showed is that this isn't just some laboratory curiosity. We're actually seeing this stuff happening in space
Yeah.
on a much larger scale.
Okay, now we're getting to the good stuff. So what did they see?
Well, Joseph and his team, they were looking at data from these space shuttles, and they started noticing these large plasmas, like huge, somewhere up to 1 kilometer in size.
A kilometer? That's bigger than any UFO I've ever heard of.
Right. And they weren't just floating around passively. They were interacting with their surroundings in these really interesting ways. Like, they seemed to be drawn to sources of energy.
What kind of energy?
Satellites, for example.
Mhm.
Satellites emit electromagnetic radiation, right?
Yeah, to communicate.
Exactly. And these plasmas, they were seen moving towards these satellites, almost as if they were attracted to that energy.
Interesting. So they're drawn to energy like a living organism might be drawn to food.
It's a fascinating parallel, right?
Yeah.
And it gets even weirder. They also saw these plasmas descending into thunderstorms.
Thunderstorms. Now that sounds dangerous.
Right, almost like they were refueling themselves from the electrical energy of the storm. And then there's the whole hunter-predatory behavior that they observed.
Okay, hunter-predatory. That's when I really start to get creeped out. What does that even mean for something like a plasma?
So picture this. You've got 2 plasmas, right, each with a different electrical charge.
Okay.
The researchers observed one plasma actually tracking and accelerating towards another plasma, like it was actively pursuing it.
Like one plasma hunting another.
And then, get this, it appeared to pierce right through the other plasma, sometimes even leaving a trail of glowing particles, kind of like a vapor trail.
Wow. That's just bizarre. So what's happening there? Is it like one plasma feeding off the other's energy?
It's a possibility that researchers are looking into. Remember those electrical charges we were talking about?
Yeah.
Well, differences in those charges, they create forces.
Right, like magnets.
Exactly.
Yeah.
And those forces could be what's driving these plasmas to interact in these, frankly, kind of aggressive ways.
It's just wild to think that something we usually associate with, like static electricity, could be behind these dynamic interactions in space.
And it's these very interactions, these lifelike behaviors, that have some scientists wondering if plasma could be the key to understanding at least some of those puzzling UAP sightings.
Okay, so we've got plasma behaving strangely in space, but this September 2024 paper we have, it suggests that things get even weirder when you factor in the ocean. Underwater plasmas. Okay, now that's just messing with me, right?
I know, right? It sounds kind of crazy.
They're like, where's the energy source underwater?
That's the thing, though. The ocean, especially during storms,
Okay.
it can generate some serious electrical currents. Remember those lightning strikes that hit the water?
Yeah, scary.
That's basically a burst of plasma right there.
Oh, right. So you're saying those plasmas could form underwater and then what, like shoot up into the air?
It's a possibility, and it's something they actually talk about in this paper. And they also go into these reports from U.S. Navy personnel, people who have seen weird lights and objects, not just in the sky, but like zooming around under the water.
Seriously. So we've got potential plasma sightings in space, in the air, and now underwater too. That's a lot of plasma.
It is, and it really makes you wonder if even a small percentage of these UAP sightings, if they turn out to be plasma, it changes everything, right?
Totally. It's like we've been so focused on the whole aliens and spaceships thing.
Right, which, to be fair, is still on the table.
Of course, of course. But if we're missing something as fundamental as plasma, it's like, what else don't we know?
Exactly. And think about what we were talking about earlier, with those plasmas behaving in almost lifelike ways.
Yeah, the hunter-predatory stuff, that was wild.
If plasma can do that, if it can mimic those complex behaviors without being biologically alive in the way we understand it.
Right, no DNA or anything.
Then what even is life, right? Like maybe we need to rethink our whole definition.
It's a huge paradigm shift. Like, what if there are other forms of life out there that are just completely different from anything we can even imagine?
It's mind-blowing. And the more we learn about plasma, the more we realize how much we don't know, which is both exciting and a little terrifying. Right?
Totally. So where do we go from here? How do we even begin to unravel all this plasma mystery?
Well, we need more data, more observations from satellites, from aircraft, even underwater sensors.
Yeah, we need to be looking everywhere now.
And we need to get better at studying plasma in the lab, especially those large-scale formations. And honestly, I think the most important thing is to stay open-minded.
Agreed. Keep an open mind. Expect the unexpected. Because when it comes to the universe, I've learned to never say never.
Me too. Who knows what we'll discover next, right? That's the beauty of science. It's always evolving.
That's a great point to end on, I think. This has been an incredible deep dive from the basics of plasma all the way to its potential role in UAPs. And honestly, I'm even more intrigued now than I was before we started. If you're as fascinated by this stuff as we are, we'll have links to all the research we talked about on our website. So keep looking up, keep asking questions, and we'll see you on the next deep dive.